guys. So today we'll be getting into a bit of roots. So it's been a while since we have essentially touched on roots. Um, what is a root in the first place? Well, it could be a part of a tree. You wouldn't be wrong there if you were doing biology. But in math, usually a root takes place where that function tends to cut the axes. Okay, so that's a visual. Now, based on these values you have here, you can identify, for example, if you were given an interval, you can identify exactly where that root is taking place. Now, in advanced maths, there are several techniques where you can find roots, and each technique is used based on the type of function you are given. Now, some of those methods include the bisection method, the linear interpolation method, or the very common Newton-Raphson method. This tends to be a favorite. Now, before you can use these methods to find your root, you have to be able to determine or identify, is there a root in a particular interval in the first place? Now, there's actually a method, and it's called the IMVT method, and this is used to determine if there even exists a root in a particular interval. The IMVT method is shortened for the intermediate value theorem. Now, before you start questions, the first thing they may ask you to find is to determine if in the first place a root exists between a particular interval. So let's consider a question. Let's consider the function being equal to, let's just say, x minus 2 all squared, subtract 7. This is a quadratic. And they're asking us to find or determine they want to determine if this function have a root, does the function have a root in the interval 4 and 5. Now, how do we apply the IMVT? Well, applying the intermediate value theorem, if you would like to call it by its full term, or IMVT for short, what we would first do is find the values of the function at these interval endpoints. So at 4, our function would simply take the value of -3. Similarly, at the end interval 5, that's I think 2. Notice how there's a change of sign between these two values, and essentially that is what you are hoping to find. Once you're testing intervals or these end values and you're trying to determine, hey, between the values 4 and 5, Does this function cross the axes, or is there a root? What you need to do is look for a sign change. You see, a sign change would be able to tell us that if one value is negative, it would lie in a certain quadrant, and if the other value is positive, it would perhaps lie in a different quadrant. Using that knowledge of change of sign helps us to be able to evaluate clearly that a root must lie between these interval values. So therefore, since this function is a continuous function, by the intermediate value theorem, there exists a root. Allow me to scroll up here. There exists a root between the interval 4 and 5. So make sure when you're answering this question, if it does come, if they're asking you to determine in the first place, is there a root that exists? Then you would apply your intermediate value theorem. You are looking for that change of sign taking place, which would highlight that that graph is cutting some axis. Hence, a root must exist between those two values. And that's essentially how you would prove that roots exist between intervals. We can look at a second example. Example 2. Let's consider the function x cubed plus 2x minus 2. Now, we would like to find or determine, does the function have a root in the interval? Now, sometimes they may write the interval like this, the special notation, so take note of this. And it's read as the interval 0, 1. Now, testing for a root, we're going to apply that intermediate value theorem. Applying the theorem, we would use the first interval value at 0. We would get our function that's just negative 2. Also, at 1, that's 1 plus 2 is 3 minus 2 is 1. Once again, you observe that there is a sign change. Therefore, by the intermediate value theorem, there exists a root between the interval 0 and 1 for the given function. And there you have it. That's how you would determine if there exists a root. In the next video, we will be looking at actually finding the true value of those roots, or perhaps I should say the value of those roots at a best approximated value, or at its best approximation. So I hope you understood everything we did today, and be sure to look at my next video. Thank you.